Yes, hello Nitin, welcome on Europedia platform, and let's start your thermodynamic snap for your final JKPSC interview for the
Yes,
post
sir.
of AE, Assistant Engineer in PWD department.
Yes,
So
sir.
Nitin, what is thermodynamics?
Thermodynamics is the study of uh, energy and its uh, uh, is the study of thermo means heat and dynamics means uh, in motion. So it is the study of energy in transit. That's thermodynamics, sir.
Acha, can you tell me some of the different forms of energies?
Yes, sir. Different forms of energies are example energy in transit. We have heat as well as work or kinetic energy, internal energy. These are all different forms of energy.
What is the difference between internal energy and enthalpy?
Uh, Internal energy is generally associated with the systems at rest, and enthalpy is the energy associated with the moving body, moving fluid.
Mhm.
Yes, sir.
You heard about low grade and high grade energy.
Yes, sir.
So how we
Uh,
can say that heat is a low grade energy? What actually makes it low grade?
uh, Actually, heat we call heat as a low grade energy because all the heat can't be converted into some other high grade energy. That's why it is called low grade energy. It is disorganized form. That's why we call it low grade energy.
Mm-hmm. Fine. And what do you understand by conservation of energy, Nitin?
Conservation of energy means that energy is conserved. We can't destroy it, uh, but it can be transformed from one form of energy to another form of energy.
So let's take an example of a pump, say
Okay,
centrifugal
sir.
pump, which
Okay, sir.
normally we utilize in our houses to lift water. Okay.
Okay.
So if you
Okay,
will
sir.
consider that pump as a system, so
Okay,
obviously
sir.
some kind of energy exchange is taking place in the pump. So
Sorry, sir.
some
Uh,
kind of energy exchange, energy, what you can say,
okay.
the transformation is taking place in the pump. So
Yes,
how you
sir.
can write the conservation of energy for pump?
Conservation of energy for pump.
Means the first law of thermodynamics, how you can write for a centrifugal pump.
Sir, we will simply write it as a steady flow energy equation. Means
Hmm?
uh,
Go ahead.
H1 plus C1 square by 2 plus Z plus the heat interaction is equal to H2 plus of C1 square by 2 plus Z2G plus of work. Here we can assume that heat is not interacting in the system, but we are giving work.
Hmm. Okay.
Yes, sir.
Hmm. Acha, pump work, pump is a open system,
Yes, sir.
and pump work we write it as VDP.
Yes, sir.
Can you develop that expression from this equation?
Uh, VDP, sir, from steady flow energy equation.
Because you are writing that equation, open system,
Yes,
but
sir.
it's a obviously it's a open system, and open system pump work we write it as
Yes, sir.
minus integration VDP. You know that?
Minus VDP. Yes, sir. Yes,
So
sir.
can you give me that expression utilizing this equation which you are writing or any other equation? Just tell me the process how you can develop that expression.
Sir, sorry, sir. Right now, I can't recall that thing.
Mhm. Okay. Okay. There is a difference between pump and compressor work. Normally, we consider pump work negligible as compared to the compressor work. What's the reason behind that, Nitin?
Yes, sir. Sir, specifically, in what application you are talking about, sir? Means power plant or matlab steam turbines
Any
or
place, like if you are taking pump, like suppose you are having pump in a thermal power plant, okay,
okay, sir. Sir,
or
actually,
you are having some compressor.
in compressor, we generally deal with gases.
Mm-hmm.
So the volume of the gases is generally high. So integration VdP is higher. That's why compressor work is higher. And for pump, volume is generally low. That's why this work is lower. Pump work can be neglected.
Then what is PMM2?
Perpetual motion machine of second kind. Uh, Perpetual motion machine of second kind is it works on a cycle and it converts all the low grade energy into or we can say it is interfering giving or to
Nitin,
thermal.
your voice is breaking. Hello.
Yes.
Now it's fine, Nitin.
Okay, okay, sir.
So, yes, yes, go ahead.
No, sir, means perpetual motion machine of second kind means that it is interfering with only one thermal reservoir and not giving heat to other thermal reservoir. Or we can say that it is converting all the low grade energy into high grade energy. It doesn't satisfy the second law of thermodynamics.
Hmm, fine. Nitin, what do you understand by reversible process?
A reversible process means a process in which we have no net effect on the environment. Means when a process is carried out in such a way that there is no net effect on the surroundings, then we can say it is a reversible process. It is a slow process. That means it's a quasi-static and all the friction must be avoided, or there is no
So
friction.
why we consider a reversible process? Reversible processes are not real processes. They're
Yes,
not going
sir.
to give us the real life realization of the efficiency or other parameters. Then why we
So,
consider?
sir, we assume reversible cycles as ideal cycles. Means we develop machines or anything in this world to so that their efficiency could match the reversible process because they are the most efficient processes.
Mhm. Okay, what is an ideal gas?
Ideal gas is gas, any gas who has which has a lower pressure and higher temperature. These two conditions are suitable for a gas to be ideal. Means there is no.
Steam is an ideal gas or not?
Sir, we can treat steam as an ideal gas, but when pressure is lower and temperature is higher.
So in thermal power plant, the steam which you are producing in the boiler, at a very high
Yes, sir.
temperature, that can be treated as ideal gas.
But their pressure is also higher, sir. We can't treat it as ideal gas. But superheated steam can be treated as ideal
The
gas
pressure of
with
superheated
a
steam is
minimum
also higher.
lesser.
Pressure of superheated steam is also higher. Nahin?
Sir, but it is away from its critical state, sir. Sorry, saturation state, sir. We can treat it as ideal gas, but errors are involved in treating it as ideal gas are little lower.
What are pure substances, Nathan?
Pure substances are those substances which are homogeneous in chemical aggregation and chemical composition.
Good.
And
So
it
what if
can't
in the
be.
mixture of sugar and water, thoroughly
Yes,
if
sir.
you mix,
Yes, sir.
thoroughly if you mix sugar in water, that mixture which you will get, that is that qualifies as a pure substance or not?
Yes, sir. It can be qualified as a pure substance.
So it's not a homogeneous mixture.
Sir, sir, it is a homogeneous mixture when we mix it because it has uniform means taste and
So what is the then what's the difference between pure substance and mixtures? Both are same.
mixtures. Sorry, sir. I need to recall
Okay,
this.
okay. Okay, Nathan, my last question is to you. Can you tell me something about Clausius statement?
Clausius statement as
closest statement associated with the second law of thermodynamics?
Yes, sir. This statement states that any if we heat cannot be transferred from lower temperature to higher temperature without any external work. This is Clausius statement.
Acha, are you ready with the kind of small presentation, 2 to 3 minute presentation for presentation related to any of the topic from this subject, thermodynamics?
Oh, yes, sir.
So go ahead. You need to first highlight the topic which you are going to present, and then you need to start with your presentation.
So, any topic in thermodynamics?
Any topic, yes. But you need to teach. You need to present that particular topic like a teacher, or you need to explain whatever best you can. That you need to try to explain.
Yes, sir. I will go with the entropy. Okay. So entropy is generally disorderness or randomness of a system. It is generally dealt with in thermodynamics. We basically study it by the process of heat interaction. If heat is added to the system, means disorder will increase, and if it is removed from the system, the disorderness will decrease in a process. Sorry. And entropy, generally disorderness, means the property time in this universe is governed by entropy. We live in a universe where if we put ink in water, we live in a universe, if we put ink in a water, disorderness will increase. Soon the ink will be disorderly mixed in the water. So time, the arrow of time is decided by this entropy, and this is all about entropy. And entropy, universe is a isolated system. Universe is an isolated system. The entropy of universe will always increase. It is also used to determine the path of a process. If it will occur naturally from one point to another point, this is all governed by the entropy of the system. In a cycle, entropy is generally less than 0 or equal to 0. If it is equal to 0, that means the cycle is feasible and it is reversible. But if it is less than 0, it is feasible, but it is non-reversible. And if it is greater than 0, then that cycle won't be can't happen in the. That's it from right now, what all I can recall.
Okay, Nitin. Nitin, it's good actually. Overall, your presentation is looking fine. But you need
Yes,
to
sir.
have more comfort. You need to have more confidence in your delivery.
Yes,
So
sir.
slightly you are looking some lack of confidence, some nervousness. I can
Yes, sir.
observe at your
Obviously.
face. Okay, but yes, don't worry about that because this is your first snap. Today I'm
Yes.
actually I'm not at my place. That's why you cannot see me. But most of the time I go with the one-to-one interaction. Okay, so next time
Yes,
we'll
sir.
be able to discuss all those things. But I hope this is fine for you and you can understand whatever I'm discussing with you. So,
Yes, sir.
and it is important for the interviewer to observe you, and not for you to observe the interviewer. That is not, I think, required.
Yes, sir.
Your technical understanding is looking fine, Nitin. But when you are giving any presentation, you need to be very much specific. First, be very clear, like which topic you are going to present, and then in point wise you need to write. You can mention point 1, point 2, point 3, so that you will be able to limit yourself. Otherwise, if you go like that, a kind of in a random manner, then obviously you will face difficulty. And there are much chances you will highlight some of the point in which then you can stuck yourself, and then you can face some difficulty in further
Difficulty
describing
in
that.
explaining. Yes, sir.
Okay, so you need to be very specific.
Okay, sir.
Mention like that, sir. I'm
Yes,
going to I'm going to present today a very small and important topic from thermodynamics, which is entropy. So entropy is a measure of randomness or disorder of a system. Entropy is a quantity which tells us about the unavailability of the system. Entropy is that property, sir, which tells us about the work which we cannot convert, the energy which we cannot convert into work. Okay, so it represents the loss of energy. So
Okay.
then, sir, entropy. Then you can mention, okay, sir, entropy for a reversible system, for a
Yes.
reversible cycle, we can write it like that. So and like that you can explain, define it. So be very
Okay, sir.
specific, point wise highlight, and at last you need to make some kind of conclusion. Okay.
Okay, sir.
लास्ट में आप क्या बोल सकते हो कि सर देयर इज according to entropy we can, in terms of entropy we can define second law of thermodynamics. Sir, in a
Okay,
real
sir.
process, always entropies of the universe is going to increase. A real
Increase.
process
Yes, sir.
is not possible in the decrease in entropy of the universe. Okay, so that also
Okay.
you can highlight. तो conclude करना पड़ेगा. First highlight some of the key points, point wise point, make some important conclusion out of that, and then last you need to conclude. Okay, overall that
Okay.
I observed your technical understanding is looking fine, but some slightly more things you can refine. Okay, like
Okay, sir.
I asked you about the energy. So
Mm.
different form of energies are what, like the internal energy, kinetic energy, potential energy, heat, work. These are
Yes,
the
sir.
different forms. You can
The
define energies into three categories. One is the stored form, another is a transient form.
transient
That
form. Yes, sir.
stored form of energies are what, the internal energy, which
Internal,
the energy which
obviously.
is stored at the molecular level. Kinetic energy,
Okay.
potential energy, these are the bulk energies. Then we are having the transient form, heat and work. Okay, like that.
Yes, sir.
Then I asked you about some expression. Okay, some
Yes, sir.
expression for the
Mm.
work,
Pump. Yes, sir.
pump work.
Yes, sir.
Okay, so pump work, that also you can easily get. How? You need to develop some expression. You are, when you are writing the a kind of system equation, the steady flow energy equation, then you can go with the suitable assumptions.
Okay.
Okay, you are highlighting about that ki, sir, first whenever you are highlighting any equation, you need to go with the suitable assumptions ki, sir, in pump we can go with the
Steady flow
steady flow.
device.
Okay,
Yes,
there
sir.
may be unsteady flow also. Okay, and then go with all suitable assumptions. There is no heat transfer. Okay,
Yes, sir.
and then you can further replace the enthalpy term.
Okay.
Okay, you can replace the that potential energy changes you can neglect. In
Neglect,
pump, actually
obviously.
what we are doing, we are utilizing the pump work which we are utilizing,
To increase
that
the
is going to raise the
pressure
potential energy
energy.
of the water.
Yes.
Okay, so
Yes, sir.
from that equation, the final conclusion what you will get is what, the enthalpy change will be negligible. Why? Because
Yes,
there
sir.
is no such significant change in the temperature of the water we are going to observe when we are
Yes,
lifting
sir.
it
Yes, sir.
through some water. Okay, lifting it through some pump, there will be no heat
Yes, sir.
transfer. So equation what you will get, the H1 H2 will be same.
Yes,
There
sir.
will be no heat transfer. Velocity changes are also negligible.
Yes,
Then
sir.
the GZ1 minus GZ2.
These are also
Okay, actually, the work will be negative because you are doing work on the system.
work on the
Finally,
system,
it will be
obviously.
what? The ZZ2 minus ZZ1.
Yes, sir.
That is a work which you are doing on the system. So that is a final, what you can say, the energy balance equation or the conservation of energy you are going to get
Energy.
from
Okay.
pump.
Pump.
Is it clear? Is it?
Yes, sir.
Okay. Now let's go into that part. Like I asked you, how you can get that expression,
Okay,
the
sir.
open system work. Is it clear? From that equation, obviously, you will not be able to get. Okay.
Yes, sir.
From that equation, you can get open system work equal to change in enthalpy,
Yes,
DH.
sir. Yes, sir. Yes, sir.
That you can easily get.
Yes, sir.
Okay. How you will get that? If you
From
assume
the
there is no heat transfer, potential energy change is neglected, you will get
yes,
the
sir.
work equal to DH, change in enthalpy. Then if you
Sir,
utilize, there is a
sir,
equation
please
known as
wait a
TDS
minute.
equation. Yes, Nathan.
Yes, sir.
Nathan, you know about TDS equation.
Yes, sir. TDS equation.
Uh,
Yes.
so in that equation, if you recall, TDS equal to DH minus VDP.
Minus VDP. Yes,
Mm.
sir.
So if you assume
TDS
process
equal
as the reversible adiabatic
reversible
process,
process.
so
Okay, sir.
reversible adiabatic, that process is also known as isentropy.
Yes, sir.
Okay, so DS will be 0. Then what you
Yes,
will
sir.
get? You will get
Obviously.
DH equal to VDP. So from that you can
Okay, okay.
represent open system work as VDP. Okay.
VDP. Oh,
So these are
okay,
two
sir.
things, like how we can represent the work as VDB. That is the first thing second thing I asked, and the first thing, like how you can write the energy balance. So merely writing the steady flow energy equation is not the energy balance. Are you getting? That is energy balance for
Okay,
any
sir.
of the open system, na? Nathan?
Yes, sir. Yes, sir.
That's energy
Yes, sir.
balance for pump also, turbine also, heat exchanger also,
Anything. Yes,
anything.
sir.
But how you are concluding actually for pump, that matters. So one by one, step by step, you need to conclude, and then you need to write. This our pump is a device which we utilize to raise the potential energy of the water by doing some work input, and that equation you need to give me. You know, these are work equal
Yes,
to
sir.
the raise in potential energy. Fine.
Okay, sir. Okay, sir.
I think the remaining all question which I asked you, those questions you answered, Nathan. Okay.
Thank.
So overall, it's fine. I feel good potential in you, and if you revise this subject thoroughly, I think then easily you will be able to get through the interviews. Your technical understanding is looking fine. So watch the marathon class, revise the
Okay,
subject
sir.
again, and if you feel, you can again join me for your snap.
Thank you, sir. Thank you.